Hello students, in the previous video we took some example on convolution integral. Now here this is a different kind of signals for which convolution has to be performed. Given, find the convolution of x of t and h of t for the following figures. Now if you observe the figures, x of t is a rectangular pulse here and h of t it looks like a ramp signal. Now x of t is having an amplitude 2 from where to where, for value of t which is less than or equal to plus 1 and greater than or equal to minus 1. From minus 1 to plus 1 it is having amplitude 2, and for other values it is 0. Now coming to this part, that is h of t, if you observe, it looks like a increasing ramp function. So you can take the slope at any point of this. If you take here, it will be 1 by 1, that will be 1 only. So if you take this region and this region, it will be, you will get minus 2 by minus 2, again it will be equal to 1. So wherever you take the slope of this h of t, it will be equal to 1. So that means it is nothing but a unit ramp function. Now how do you define unit ramp function? Is h of t is equal to t. So this is how we define these two signals. Now for performing convolution, I go with y of t is equal to h of t convolved with x of t, which allows me to write the equation in this way: y of t is equal to integral minus infinity to plus infinity h of tau x of t minus tau. Now let's plot. I already plotted the signal h of tau and x of t minus tau. I'll just explain the step how the plot has been done. Now h of tau, just replace t with tau, you will get it. Now x of tau, I have replaced t with tau, I got x of tau now. But to get x of t minus tau, I have to take x of minus tau considering t as 0. So the same step I am doing here also. So this is what I get when you perform time reversal. This plus 1 will become minus 1 and this minus 1 will become plus 1. But if we have to express this in terms of tau, the signal is x of t minus tau. So here tau will be equal to t, and this one is tau is equal to t minus 1. So this process I have already explained this, so that's why I am not taking much time here. Then this point will be t plus 1, right side towards the origin. So this is t plus 1 and this will be t minus 1, t minus 2, t minus 3 to the left side, and to the right side from the origin it will be t plus 1, t plus 2, t plus 3 and so on. Okay. So now onwards, this end of x of t minus tau will be identified with t plus 1 and this end is identified as t minus 1. So observe this, this signal is having only two divisions, that is minus 1, from minus 1 to 0 and 0 to 1, and this signal is having four divisions, that is minus 2 to minus 1, minus 1 to 0, 0 to 1 and 1 to 2. So that is the reason I have taken one h of t as a constant one. Now if you start performing the operations of convolution, so let's plot this. I will write the static signal here first, that is tau, h of tau. So minus 2 to plus 2. Now this x of t minus tau, which is my shifting signal, so it will look like this: t minus tau. These two ends, this is t plus 1 and this is t minus 1 with amplitude 2, and this is the origin, or you can call it as t. Okay. Now this will shift from this end to this end. That means you can see both are deterministic signal. We start from point where there is no overlapping, and then we move on further and we'll get some regions where the signal is getting overlapped, and then we move on to the point where this entire signal passes this index, that is 2. It will pass all the index. That means this point t minus 1 will pass all the way this index 2 in h of tau. So till there we have to perform the shifting operation, and for each instance, if you get a different time limits, we have to find y of t, and in the last we have to combine all of them to get our plot here. Okay. So let's start performing the convolution operation, and to keep this simple, I am just writing this x of tau here. So first I have to figure out where there is no overlapping happening, because we have, while plotting y of t, it is necessary that from where the signal exists and where the signal doesn't exist, at which limit. Okay. So I will place this end, that is t plus 1. Okay, this end is t plus 1 here, and this is t minus 1 here. This is my x of t minus tau. Now what you can call this case 1, call this as case 1. So here you can see we can define this case as t plus 1 is less than minus 2. Okay, can simplify that, just moving that t here, 1 here, t less than minus 2 minus 1, that is t will be less than minus 3. So this is required because while plotting y of 3, you should know what, from where y of t is 0 and where y of t will exist. Now in this region you can see, if I keep this end t plus 1 less than minus 2, there will be no overlapping. So if there is no overlapping, then h of tau and x of t minus 2, the product of these two will be 0. If the product of these two is 0, then obviously y of t will be 0. So that means the first case says for t plus 1 less than minus 2, or for t less than minus 3, our y of t will be 0. Okay. So next case, I will move this t plus 1, I will keep this somewhere in between minus 2 and minus 1, and let's see what happens. Okay. So let's take case 2. Okay. So first I will plot my static signal here. H of tau, this 2, minus 2, minus 2 and 1. Okay. So the amplitude is plus 2 here, and here it is minus 2. So take the shifting signal now. As I told you, I will be keeping this signal here, because I told you this will be easier for me to get the limit. So t plus 1 is placed between minus 2 and minus 1, and remember this one is having only 2 divisions and this one is having 4 divisions. So this is my x of t minus tau. Now observe, we have a overlapping region here. The signal is overlapped when this end of t plus 1, that is x of t minus tau, is placed between minus 1 and minus 2. So how do you define the case? T plus 1 is less than minus 1 and it is greater than minus 2. So simplify this, moving one this side, you will get minus 2 here, and moving on this side here, you will get this. If you simplify this, you will get the limit like this. So t greater than minus 3 less than minus 2. So this is for our end signal y of t to plot. Now in this duration, what happens to our y of t, that we have to find out. So y of t is equal to, now from where to where it is overlapping, you can see it is overlapping from between minus 2 to t plus 1. So the overlapping region is between minus 2 to t plus 1 here, minus 2 to t plus 1. So what is h of tau? X of t minus tau. So let's substitute the value here, minus 2 to t plus 1. So the value of h of tau, this is a ramp signal, it will always remains the same, that is t, but since it is h of tau, we will represent it as tau here. Okay. And what is the value of x of t minus tau? That is, the amplitude of the signal is 2. So therefore, into 2 d tau. Okay. So that means we have to integrate 2 into tau. So if you integrate this, it is just nothing but integral of minus 2 to t plus 1 2 tau d tau. I am not elaborating this further. I am just giving you, if you integrate this, the integration of 2 tau is 2 tau square by 2, and if you apply the limit 2 tau square by 2, where limit is minus 2 t plus 1. So this, for this instance, I am writing this. If you apply the limit and simplify, so you should get something t square plus 2t minus 3 as the answer. Okay. So this is the second case. Now in the next case, I will move this t plus 1 here. So that means I will keep this between minus 1 and 0. Let's see what happens to the signal now. Again, I will draw the signals here. So I'll write this case 3, and let's plot this. So this is the signal, and my shifting signal. Now I am placing this t plus 1 here, t plus 1 here, and since I told you this is having only 2 divisions, so from here to here first division, and from here to here the second division of the signal. So that completes the shifting signal x of t minus tau, because you have to be careful, some, and the next instance the complete signal might overlap. So this is where t minus 1 is there, and this is where t plus 1 is there. Now you can observe the overlapping region again is this much. So this is where the signal will overlap, and as you can see, the overlapping region is again from minus 2 to t plus 1. So this is the overlapping region. And how do you define the case here? So this case is defined as t plus 1 less than 0 greater than minus 1. So if you simplify this, so it will be t greater than minus 2 greater than minus 1. See here, the previous case was t less than minus 2 greater than minus 3. Now it is greater than minus 2 less than minus 1. Okay. So the continuity is there. And you can observe during this duration what is y of t. To find out that y of t is equal to, now what is the region that is overlapping? Again it is minus 2 to t plus 1 h of tau x of t minus tau d tau. Now, if you observe, we have the same limit minus 2 to t plus 1 as in the previous case here. So that means if you integrate and substitute the value, you will get same output value for y of t here. So 2 tau d tau. So if you integrate and apply the limit, you will get the same value, that is t square plus 2t minus 3. Okay. So if you want, you can eliminate this step by just simply mentioning that case and all, or if you want more clarification, you can keep that step as well. Okay. Now in the next step, I will take this t plus 1 and place it here between 0 and 1, and let's see what happens to the signal. So let's take this as case 4. So depending on the problem, the cases might increase. Okay. And if you want to keep it simple, you can combine these two cases, and while writing y of t, you can make it as a one particular range, and because both are having the same values here. So while concluding that, I will tell you how to write y of t here. Now considering the case 4, let's plot the signal here, the static one, h of tau. So now in this case, as I mentioned, I will place my x of t minus tau, that this end here, t plus 1 here. So remember, it is having only two divisions. From here to here you will get one division, and from here to here it is two divisions. So that means the entire signal x of t minus tau is overlapping, and do mention this point t minus 1. Now if you take from where to where it is overlapping, so this is the region it is overlapping in this case. Now if you observe, it is overlapping between t minus 1 to t plus 1. So this is the overlapping region in this case. Now how do you define this case? So you can define this in two different ways. Either you can define in this term, that is the like t minus 1 is less than minus 1 greater than minus 2, or you can define this with this end like t plus 1 less than 1 greater than 0. Both yield the same limit. T plus 1 is less than 1 greater than 0. So if you simplify this, so you will get 0 here and you will get minus 1. Okay. Or you can check like this. What if I define this in t minus 1? You can try that one. T minus 1 is less than minus 1, because t minus 1 is placed here minus 1, and it is greater than minus 2. Again, if you simplify, so this minus 1 will become plus 1, minus 1 plus 1 is 0, and here minus 2 is there, become plus 1, minus 2 plus 1 is minus 1. So in both the instance, you will get the same limit. So you can take the limit or define the case using this end, or you can take the limit by using this end. Okay. So the limit part is over. Now in this limit, what happens to our y of t? So let's check that. Now y of t is equal to integral of, so where till where it is overlapping, the overlapping region is between t minus 1 and t plus 1. So that is the region we have to write t minus 1, t plus 1, h of tau, x of t minus tau, d tau. Now the value of h of tau is tau, and x of t minus tau is 2. So again 2 into tau. You can see this, the value of x of t minus tau is 2, and h of t minus tau in this particular duration, it is tau only. So any point it is tau. Why I have already explained that before. So t minus 1 to t plus 1. So now this, again if you integrate and apply the limit, so you will get the value as 4t, I'm not elaborating on that integration part here. So you will get something like this. Integral of 2 tau with respect to tau is 2 tau square by 2, limit is t minus 1 t plus 1, which will yield you the value 4t. Okay, you can try that. So next case, I will move this t plus 1 here between 1 and 2, and meanwhile I have to move this end also, and let's see what happens to the signal. So let's define the case here, case 5. So this is plus 2, this is minus 2, amplitude here is minus 2, plus 2, 1, and write 1 here, minus 1. Next here in this case, I will place my starting end here t plus 1. So from here to here 1 division, and from here to here it is second division. And again you can see the entire signal is getting overlapped. So this particular region is getting overlapped. So this is my x of t minus tau. So this entire region is getting overlapped. That means again the limit is same, t minus 1 to t plus 1. And how do you define the case here? So as I told you, you can mention either taking this end or this end. So I will stick to the first one only, t plus 1 less than 2 greater than 1. If you simplify this, so you will get 0 to 1. You can see the continuity, minus 1 to 0, now 0 to 1, it is there. And in this duration, what happens to y of t? So again the limit is from t minus 1 to t plus 1, this is the overlapping region, and you will get the same answer like before if you substitute this. So again you will get 4t only, because this t minus 1 to t plus 1, same duration, and if you apply the value of h of tau and x of t minus tau, again you will end up with the 4t only for this case as well. So let's see what happens in the next case. So it's not mandatory that you have to show all the steps here, but you should know how you got that one. Since it is, I will explaining this each step in detail so that you can understand. So I will take a little bit more space here. So next, in the previous case, I have placed t plus 1 here. Now I will place t plus 1 here, this part, t plus 1, and here is one division, and here it is the second division of signal. So both will have the same amplitude 2 here. So this is my x of t minus tau. Now the overlapping region is this much. from where to where it is overlapping. Now it is overlapping from t minus 1 to plus 2. So this is the overlapping region. Now this is different from the one we got in the previous case. And let's see what is the value of y of t in this case. How to define this particular case now? Now t plus 1 is less than 3 but it is greater than 2. If you simplify that, you will get t varying from 1 to 2. Now come to this, in this duration, y of t, what is the value of y of t? Now it is overlapping from t minus 1 to 2, h of tau, x of t minus tau d tau. Substitute the values t minus 1 to 2, again you will get 2 tau d tau. So integrate this, so it is 2 tau square by 2, limit is t minus 1 here. So for this, if you apply the limit and simplify, you should get minus t square plus 2t plus 3. So this is the value you are supposed to get. Okay. So this is the third case. Sorry, I mean sixth case, I guess. So next, move further. Case 7. Okay. Now the overlapping signal. The previous case I have placed between 2 and 3. Now I will place this between 3 and 4. So this is my t plus 1 here. So the second division, again it is coming here, x of t minus tau with amplitude 2, and this part is t minus 1, and this is the overlapping region, only this much. So again you can see this, the region that is overlapped is between t minus 1 to plus 2. So you will get the same answer as before in this case as well. Now as I told you, you can mention this case with the two options. So I will take this one for t plus 1 less than 4 greater than 3. If you simplify this, you will get t uh, less than 3 but greater than 2. Now for this case, what is y of t? Y of t is equal to integral of t minus 1 to 2 h of tau x of t minus tau d tau. So substitute the value. So this is the same as the previous, same limit t minus 1 to 2. Again you will end up with minus t square plus 2t plus 3. Okay. Now I think this may be the last case. This is h of tau. Okay, I will write the signal here only. In this case, I will place my t plus 1 between 4 and 5 here. So 1, 2. And I can see this, the signal has completely crossed h of t, h of tau here. So both end has crossed h of tau, and this is my x of t minus tau. So as you can see, there is no overlapping. So how to define this case? T plus 1 is less than 5 but greater than 4. If you simplify this, it is okay. Now there is no overlapping happening here. That means x of tau and h of t minus tau will be 0. Since there is no overlapping, h of tau and x of t minus tau, the product of these two will be 0. So therefore y of t is equal to 0. So remember, we started with the first case where there was no overlapping here. So that's why we got 0. Now we moved this signal step by step and we got the values for y of t in each cases here, here, and this is the third one. Sometimes it is repeated, but we have to make sure the signal pass from this end to the another end. Okay, so each step I have explained this, and for each step we have calculated y of t, and here at this point the signal has completely crossed h of tau. So that means again there is no overlapping, and if you move further, the signal will again no overlapping will happen. So y of t will be 0 only. Now we considering all these cases, we have to conclude our y of t. So finally I will be concluding y of t considering all the cases here. So first I will take y of t is equal to, so first time it is 0. Where it is 0, go to case 1. So if you go to case 1, y of t is 0 for t. I'll take this limit, t less than minus 3. Okay. So that is what I will taking here for t less than minus 3. Then we got the another duration here. So case 2 and case t. If you observe this, case 2 having the same limit minus 2 to t plus 1, and case 3 is having minus 2 to t plus 1, same limits. So that means for two different duration the value of y of t is same, and that means I will take from minus 3 to minus 2 and minus 2 to minus 1. I will combine this and I will write it like y of t is equal to t square plus 2t minus 3 till where, for value of 3 greater than minus 3 and less than minus 1. Okay. So if you go to case 4 and case 5, again you can see we have repeated signals t minus 1 to t plus 1, t minus 1 to t plus 1. From where? From minus 1 to 0 and 0 to 1. We got 4t, 4t. So that I am writing here. So y of t is equal to 4t from where to where? Minus 1 to plus 1. Okay. Next, for these two cases, from, yes, this one, from plus 1 to plus 2, we got minus t square plus 2t plus 3, and plus 2 to plus 3, I got minus t square plus 2t plus 3. So combining these two, y of t is equal to minus t square plus 2t plus 3, from where to where? From 1 to t and from varying from 1 to 3. And as you can see, from 3 to 4 there is no overlapping. So y of t is 0. How to conclude this? Y of t is 0 for value of t which is greater than 3. Okay. Or you can also write less than or equal to, because it's a continuous time signal. Okay. Yes, in this case. So this is the final answer, y of t. Uh, so this step is little bit lengthier, but to explain exactly what happens, I have taken each cases and I have written the diagrams for each step, so it will be easier for you to understand. So do explain this using the steps and mention the steps carefully. Depending on the problem, it might vary. Some will take less steps, less cases, and some example take more cases. And this is our final answer, y of t here. Now, you can also plot y of t as is shown in the previous case by applying the values here. It says t for t less than 0, y of t is 0. Now, between minus 3 to minus 1, for this expression, you have to apply the values minus 3 first and minus 2 and then minus 1. So, three different values you will get. So, may note down the amplitudes and complete the plot. And from minus 1 to plus 1, it is 40. Since it's a continuous time signal, you can plot the signal easily compared to the discrete time one. And from plus 1 to plus 3, apply the values 1 and 2 and 3. Three values you have to apply this expression, you will get three different values, and for that values you have to make a mark in the plot and complete the lines. You will get the plot of y of t. Okay. So hope you have understood the step, and I would like to give some examples for you to try by using the same methods. And I hope I'm expecting that you will get the result for this. So first signal I am taking, I'm giving a simple one. Take this one here. I'm just slightly varying the signal. The signal is varying from 0 to 1. This is the x of t with amplitude 1 here. Now this one, this is h of t. Now this h of t, I am giving a exponential signal, and the value of this signal is from 0 to 1 itself. Amplitude is 4 into e power minus t. So try this one, apply the same steps and try to get the result. And let me change this further. So to make things interesting, instead of this, let me try this one. X of t with amplitude 1 varying from minus 2 to plus 2, and here h of t is varying from 0 to 1. The signal is having an exponential signal 4 into e to the power of minus t. So this is one problem, and the second one, uh, just give you this, like y of t is equal to u of t plus 1 and u of t minus 2. So this one, another one I want you to try. Okay. And try this one as well. A triangular pulse minus 1 to plus 1, let it be your x of t with amplitude 1, and this you convolve this with yes, with a rectangular pulse varying from minus 2 to plus 1. Amplitude, just keep it simple, 1 only. Okay. So try these three examples on your own and try to get the result. The video is a little bit lengthier. Hope you have understood the steps. Thank you for your time. And if you have any queries, do reply. Thank you.